Hello everyone, my name is Nathan and today it's time for the third episode of Shenzhen I. First of all, thank you so much for the support on the first two episodes. It has been quite surprising, but a lot of people have found their way here. Now, I didn't intend to go on for too long, but we are gonna continue for as long as I can solve the puzzles. So why don't we go ahead and have a look into the concept mail first of all and see what we were left with. Currently, there are three things we could do. We can go for the infrared sensor, we could do a virtual reality buzzer, or we could do something totally new using the components we currently have. So we could, for instance, program a game of some sorts, but I'd rather go for the puzzles right now. Maybe we take care of our own ideas another time. So I would suggest we're gonna start with the infrared sensor first of all, because it seems to be important. Alright, there we go guys, look at this, we have a couple of new things to utilize. Let's actually first read through the information here. RTS, which is this thing right here, is a simple input connected to a D22415 real clock module. Okay, then the sensor is a simple input connected to a infrared sensor. Okay, cool, so here we get a lot of inputs, that is good. Alarm is a simple output connected to a silent alarm. The task is, the alarm should be turned on whenever the sensor reads at or above 20 between the specified on and off times. So we have on times and off times, interesting. The on and off times are set by the operator using switches that can be read as XBus inputs and use numerical values compatible with the DT2415. Okay. So to get this straight, let's have a look into the verification. We have the input, the RTS input, then we have two more inputs right here and a sensor input. So the sensor is gonna give us a signal, and if it is above 20 while we have an on and off time going on. Okay, so I see. So kind of these three things belong together, and then we have the sensor for which I'm gonna get a module, and then we have basically both information. So let me get this straight here. I have no idea if we are actually gonna use the MC6000 module instead of the lower tier CPU, but we're gonna try to make the best out of it. So this module here should decide whether or not the on and off switches are turned on, right? So only if we have an on signal, then we want to send the signal further into this thingy-majingy. Right here, the sensor is being checked if it is above 20. So when it goes above 20 or so, we want to have the alarm output as long as the RTS signal is on. Oh man, I'm not sure if I understood this correctly. Okay, let's think this through. We first of all want to decide for the on and off times, because that will be a simple output that we can actually read. For instance, 1 for true and 0 for false, or on and off. Good, so we are gonna start with this bad boy, I guess, here, and we want to hook this up to P0 or P1. Let's just go for P0 since that is so easy. And then we have an off time or an on time, which I'm gonna plot down right here, and we're gonna drag a line to the X0 since this is an XBus output / input. So comparing this input with the RTC input, I think we might be able to decide whether or not it should be turned on, the output. So P1 would be our output. So the next thing we need to do is hook up the off time. And can we do this in a similar way? Could I, for instance, bridge down here? Is a bridge really the best solution? I guess, well, I guess it works out, right? And then we could also have a bridge right here to continue this. But first of all, let's think about our arrangement here. Basically, what I want to have is an on state, and I also want to have an off state at some point, right? Okay, what do we want to happen if it is on? Then we definitely want to move number 1 to P1, which is our output right here. So that basically means the signal told us to turn on the sensor. And while it is off, we want to do the opposite. So move 0 to P1. However, we need to have some kind of a comparison first of all, and I think we can do this right here. If we test equal P0 to X0, so only if they are equal, then we want to actually do this. And if they are not equal, then we don't want to do this. So the off time is actually dominated by this guy, which is our X1 input. So I have to use P0 and compare that with X1. Right? Okay, but now we need to have a loop going on because we need to test this every step. So I would say if it is not true, then we simply jump to the on label. And the same thing right here. We want to jump to the off label just so that we can loop this until the state actually changes. Okay, now is there a way for me to actually test this? What is happening? Partner, oh, of course, we forgot to sleep, and we should do this before, right? We should sleep so that it counts actually, otherwise we're just gonna jump right in this cycle without the sleep. That wouldn't be good. I'm gonna do the same thing right here, sleep 1, okay? And now theoretically at least we should be, look at that, okay, that is actually amazing. Let's go through this a little bit slower so we can see that it currently is checking, and we can see there's an input signal of 93 and there is one of 70. So that basically means as soon as the RTS signal goes to 93 and we can compare these two signals, then it will move 1 to P1. And if it reaches 20, this RTS signal, and gets compared right here, it will move to 0. So that means we can actually focus on this P1 output, and we can just go step by step. Right now we are going all the way up and we should be reaching 93, which meant it actually output a 1. And we can continue and we will be reaching 20. There we go, 20. Now it has turned off again. Okay, nice, good, that already works out. Now we have this functionality, we need to take care of the sensors still, and for that I'm gonna grab myself another module. Can we actually have this guy right here and hook it up to P0? So what do we want to check here? We basically want to check if the sensor input is greater than 20, or actually 20 and higher. So we could say test greater than P0 and 19. So if it is greater than 19, then theoretically we want to output the signal, right? If that test was successful, then we want to move an output. Now let's see, we need this third module, because here we decide whether or not the sensor is active, but we still need to compare it to the output here, because only if we get a 1 right here from this bad boy, then we want to actually trigger something. So let's see, for instance, I could put this a little bit over here. Yeah, that seems alright. And then we hook those guys up, these two buses, so I can send a signal through the X1 and receive it at X0. So let's say if this comparison does actually turn out true, then we want to move 1 to X1. And if it turns out to be false, then we want to move 0 to X1. And after that, I guess we want to sleep for 1 time unit. I'm not sure if I can do these comparisons. Maybe I first have to move it to the accumulator. Well, maybe we first of all hook stuff up the way I intended it to be hooked up. We're gonna need another bridge and we're gonna hook this up right here to the P0. I feel like I'm doing this too complicated, but we are gonna label another on state here and we're gonna say test equal P0 to 1. So this P0 that comes from right here. So as long as we have the on time going on, it will be sending and receiving a 1. And as long as that is the case, we want to move X0 to P1. Isn't that right? So that basically checks, do we have an on signal from here? And if that is the case, we want to move the input of X0 to P1, which is going to go straight to our alarm. What is the input exactly? I have to check. The input is going to be 1, but we actually want 100, right? So why don't we just go ahead and change that to 100? I think that is a good idea. But since we can take this 100 signal from X0 and we put it to P1 directly, we should be able to test the alarm. Okay, so after we've sent the signal to the alarm, I would say we're gonna sleep for 1 time unit and everything should be fine. Let's see if that works. Oh no, parts not sleeping, blocked on the right. Interesting. Let's actually do this step by step. So we are sending a 0 through x1 and then we cannot go any more steps. So let me actually test this quickly. I want to change this. Instead of testing greater than directly from P0, I want to move it to the accumulator. So we're gonna move P0 to accumulator. And then we're gonna test greater than accumulator 19. That was not it. Okay, so good to know that did have no difference whatsoever. I'm not sure I understand. I mean, this part is sleeping, but it tells me that there is a problem with it not sleeping, even though this command should be executed next. So that's one thing I'm confused about. Another thing that I just realized is that we also have to use a move 0 to P1 in case this turns out to be negative, because we need to shut down the signal, right? As you can see right here, we want to enable the signal and then shut it down again. So this can of course only occur if we have a condition for that. But other than that, I'm quite confused why this is not working. Let me quickly figure that out. Oh, look at that. I just realized I totally don't need that bridge. I can just do it like so. Yeah. Okay guys, it is now literally 20 minutes later or so. I have tried out a few things and I tried to reconstruct it the way I had it. So what actually worked was moving what we have in X0 first to the accumulator before we do any testing. And then, instead of moving what we have in X0, I just move the accumulator to P1, and for some reason that seemed to be working out. And then here I'm just moving 0 to P1, so I don't have to change anything about that. However, I do believe that's the way it actually worked out now. And about this step, I'm really confused. I just had to figure out a few things. But generally, I would say it's just safer to move stuff to the accumulator if you're trying to do something with it, especially comparisons, etc, etc. But like this, look at that, it seems to be working out. Here the alarm needs to be on and off and on again. It's crazy. It's a beautiful contraption, and unfortunately the last step about it I just figured out by coincidence because I was confused about accumulator stuff and moving it correctly, but there we go, we did it. That is nice to see. I think we managed to do a great job. Anyways, let's see what else we can do. Back in the concept mail, we find the virtual reality buzzer. We also have unlocked a new puzzle. However, let's take care of this one first of all. I already checked it out a little bit and I made a little test design. It didn't work quite out, but I think I will be on the right track with our new design that we're gonna try out together. So let's see what we are starting with. We have this signal input right here with X buses. We have an RX signal and a TX signal. Let's read. Radio RX is a non-blocking X bus input connected to a radio receiver. Okay, so this is gonna be an external input. Buzzer is a simple output connected to an electromechanical buzzer. And then when a data packet is received over the radio, read it and execute the corresponding command in the following table. So if it is 0, then we want to power off and turn off the buzzer. And if it is 1, we want to power on and turn on the buzzer. Okay, sounds easy enough. That actually sounds easier than the previous puzzle. Okay, we're doing this with virtual reality headsets apparently, so let's maybe simulate this just to see what's going on. Okay, so if we go at this step by step, we probably have an output right here. Let's see if we can read that like this. Yeah, minus 999. I guess that means no signal at all. Then we advance and we have a signal 1, which means we are activating a phase where we want to turn the buzzer on and off until we get another signal from the RX, which is gonna be, I guess, 0? Why doesn't that change to 0? I'm not so sure. Okay, the TX doesn't seem to be doing anything at all, so I don't think we need that, but we are definitely gonna need the RX signal. We have hooked this up to X0, and I think I'm gonna use P1 directly in order to hook up the buzzer, and now we can actually set up a few things. For instance, I'm once again gonna have my on and off statements or labels so that I can jump back and forth. And I guess what we want to do when it is on, then we want to move 100 to P1 right there. So you can see as soon as it is on right here, we want to enable the buzzer, but after one time unit, we want to disable it again. So I guess what we can do, this might be a little bit too complicated, but I'm just gonna try it. We might want to sleep for 1 unit, then we move 0 to P1. So now we would be at this stage, and then we need kind of a loop to get back. So we kind of want to check, are we still in the area where it is enabled, where we have not yet received a 0 from the RX, then we want to go back to this state and enable it again. So that means we first of all want to sleep 1 more time unit and then basically jump back to this point, but only if it is still a 1. Okay, let's sleep for 1, I guess. And then we are gonna do our test. So test equal, and that is gonna be x0 that we want to compare with 0. So if x0 is 0, and of course that is only the case if we start with the on condition first. So I want to make sure that is still within the on label. So what do we do if that is the case? Then we want to go to the off stage, right? So that means we want to jump off, which at the moment is not necessary here. But maybe it's going to be as we add more lines. Let's see. If it is not the case, then we want to jump back to on, because we want to start over with the same thing. Oh, couldn't we take away 1 sleep? So maybe let's go through this step by step just to see what is going on. So, no, we are starting with on. That of course is not good. In the beginning it is not on. What if we did a jump off here? And then at this point we would add a sleep 1, because that's what we need anyways at the end of the script. No, that would result in an infinite loop right here. That is not good. What we could do right here is maybe do a test equal x0 and 1, just so that once we have a 1, our first one, it is going to jump to the on. So that means plus jump on. And that would mean we could set this to jump off. So we start at the off stage, and then it is going to do this test. And if it fails, we're gonna sleep for 1 second and then jump to off again. Let's see if we can go through this step by step. So we are now testing it. It is not, so we are sleeping, then jump off again. Okay, that works out. Now it is a 1, which means this test is gonna fail. So we are jumping to on. And now we are sending the signal up, so that should theoretically still work out. Oh man. That is great. So we sleep for 1 second and we moved down again. So we are now at this point. Now we are testing again in order to see whether or not we still have a 1 going on, which we actually do. So we're gonna jump back to the on. And this is also working. Look at that! I'm actually a little bit surprised I got this. I still feel like we have too many lines at the moment. But now this already worked. Let's actually simulate this. Okay. Oh man, this is great. But I do know we have too many lines, guys. Don't worry. You have been complaining about this for the first 2 episodes. I'm trying to tune it down. Okay, seeing that I'm doing this test and then directly jumping to the on status, maybe we can actually do this test up here. So we're gonna test equal x0 to 1. And if it is true, then we are gonna continue normally. But if it is false, we are gonna jump to off. Okay, so I can take away this jump to off. And that would also mean we don't need this comparison here anymore, and we also don't need the jump on anymore. All we need is a sleep. We can actually take this away and make 1 line out of it. That is already much better, I would say. Now, one more thing feels a little bit off about this. Yeah, we don't need the jump off, of course. So, because if that is true, then it's going to continue with the next lines anyway, and we are jumping to off directly. So we don't need this necessarily. And that leaves us a lot of space. I don't see anything that can be shortened down. How many lines is this? Oh, it's actually 9 lines. I think that might actually fit in the small module. Let's actually try to copy this out. Yes, look at that. It works, but the pins are, of course, not connected. Yeah, we can do that. Don't worry. We just do this. And I think I got all the commands in line, and let's simulate this and hopefully not fail. Yes. Oh, this is a beautiful game. It gets a little bit taxing. Holy cow, those 2 puzzles actually took me a while off camera thinking. running through all the tests successfully, but I did solve the puzzle in a way a lot of other people did it, power usage wise, and my production cost is very low because we managed to get down the lines. My first result was also with higher production cost of the better CPU. But anyways guys, now we can return to email and we have unlocked new things. Cool Dad device 2827. If you want me to continue this series, don't forget to leave down your likes and comments. Thank you so much for watching, have a great time and see you soon. Bye bye.